solving some log equations. We're going to spend a couple days on it just because there's a couple different types that you kind of have to get used to. So the ones that we're going to do today actually have log in it already, right? So the log is in the equation already built in. The ones tomorrow, you're going to have to create log equations to solve them, okay? All right, so here it just says solve the following equations, give answers as exact values, then verify your solutions. So something like this, okay? We have log base 10 of x minus log 15 equals log 0.2. So right now, guys, do you agree that they're all the same base? Okay. So something like this, we can actually do these ones very similar to what we did when we had exponential equations where we could get the same base. Okay. So what I mean by that is, can I do some simplifying here? Right? Could I move the log 15 to the other side if I wanted to? Yes. Could I leave it as is? Yes. So if you leave it as is, okay, can you put these two logs together using your laws of logs? Okay, so you guys tell me, do you want to leave it or move it to the other side? Because we're going to have to use a law of logs on one side at least. Okay, do you guys want to move it to the other side? Again, it doesn't matter. We're going to get the same answer. If you move it to the other side, do you actually have the piece that has the x isolated on one side? So I would suggest you do that. It's just one less step later because you're going to have to move something at some point in time. So if you move it right now, because you're not really sure what I'm doing yet, right? But if you move it right now, we're going to have log 0.2 plus log 15. Can we put the left side together, or sorry, the right side together? So then we're going to have log x equals, so we're going to have log 0.2 times 15, right? Because with addition, same base logs, we can use our log laws to put them together, right? So 15 times 0.2, right? So we have log base 10 of x equals log base 10 of 3. What does x equal? 3. Right? Because again, this is very similar. Can I actually drop the logs off if they have the same base? Because through the transitive property, if this is a true statement, then x does have to equal 3. If you chose not to move the log 15 to the other side, would you have had now an argument piece that said x x over 15, right, equals log 0.2, right? And then you would have dropped the logs, solved for x. Yep. Why what? Well, it's just transitive property, just reasoning, right? For those two, it's called the transitive property. That's the proof behind it. If those two statements are true, therefore x would have to, these two things right here have to equal each other. But again, guys, can you drop the logs at this step right here, up here? Quit moving so weird. Right? Can I just drop all the logs at this step here, the first step? You can. At this step here, you can just drop all the logs? No. It's just like when we had exponential equations, guys. You need one piece on one side, one piece on the other. If you just drop the logs there, you're completely ignoring order of operations. Is there a plus sign you're completely ignoring? Yes. So just like when we did our exponential equations, when we got the same base, we had to keep going, simplify, 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 until we got one base of the same thing on the left and one base of the same thing on the right. Here we're getting one log with the base the same on the left, one log with the same base on the right. Then the arguments you can set equal to each other. Right, so then you would say x is equal to 3. Now, just a quick reminder, guys, the original equation, what was my restrictions on x? Right from the beginning. X had to be greater than 0. right? Because the only restrictions comes from this little guy here. So we do have to be thinking of our restrictions, because do you think once we start solving these, we can get extraneous roots? Yes. Oopsie. So I'll do all the restrictions for each one, so you guys get used to doing them. All right, so for this one, again, just like any equation, guys, guess where I like to move stuff? I like to move stuff, anything that has x's in it to one side, anything that doesn't have x's to the other side. Is that kind of already done for us in this one? Yes. So we need to simplify it, so we'll use our log laws. Right, so simplify the left side, simplify the right side. By doing that, we're going to get one log with the base 4 on the left. We're going to get another log base 4 on the right. Then we can use the transitive property to drop the logs off. So this little guy here, we get log base 4 bracket. It's subtraction. So what are we doing to the two arguments? We are using division. Right, so there's our statement for our argument on the left. Equals, we have addition on the other side. So what operation for the argument are we going to be doing? Multiplication. Right, so these are two argument statements. Do we have the same base for our logs? Yes. Right, so they're both log 4s. So can we drop the logs off and set our arguments equal to each other? Yes. So are we good? Everybody's following me? So then we have x over x minus 2 equals what? 15. So then now we're back to 20-1, solving rational equations. So can I just multiply the x minus 2 over? Yes. So we have x equals 15x minus 30. So bring my 30 over, bring my x, my minus 30 over, become positive, take my x over to the 15, we get 14. So 15 over 7. So let's go back to our restrictions. And again, could we put it back in to check to see if it works? Yeah, but so we already know with here, it was just like when we did the radical stuff, when we had more than one radical equation, how we did our restrictions. So for this log right here, what's my restriction on that one? X has to be greater than what? 0. This one, x has to be greater than 2. Do I write both of them down? No. Which one satisfies both? So this is the restriction on the equation. Because again, you can't put the x is greater than 0, because then you're saying 1 could be a possibility. And is it? No, because it doesn't work in the second one. So when you have more than one x, it's always the one that satisfies both. Right? So before you start, you be thinking, right, where x is greater than 2. So is 15 over 7 greater than 2? Yep, it is. It's 2.14 or 2.2-ish, whatever. It does fall within that restriction. So these are ones where every single piece of the equation has the same base, so they're nice and easy to simplify, okay? And they're already set up in log form. So these ones are very similar, okay? So with this one, is this very similar to the last one I did? Except we have one that doesn't have the same base. Can you make that one have the same base? Yes, we talked about that last week. So I'm going to show you two ways you could think about this question. So could you change that 1 to a what? Right, log 5, 5. Could you change it to that? Yes. So anytime you have a constant, can you always change it so it's in the same log form as the other ones? Always. Okay. So you can, and then if you do it this way, then is it the same as what we just did above? Yes. So I'm going to show you both ways though. So if you choose to change the constant pieces to logs with the same base, which I usually find students do better with that, okay, then it looks like this. So then now it's the same as above. And again, is everybody okay? Okay. Is everybody okay with me saying that 1 is the same as log base 5 of 5? Everybody? Shake everybody's heads. Yes, yes. Okay. All right. So then if we do that, I'm just going to replace that. Then now we're left with log base 5. And then we have an x plus 1 times an x minus 3. And then equals log base 5 of 5. Can we drop our logs? Yep. If the 1 was like a 5? Like if it was 2 squared there? Then you would go. Okay, just we'll talk about what you're talking about in a second. Let me finish this one. Because again, guys, is it always just going to be a 1 there? No. So we'll be able to adjust to anything if it's not in a form of a log. Okay? We'll get there. Because again, if this is, we'll get there. If it's a 2x, can we still put a log base 5 of 5 on it? Yeah, we still can put a log base 5 of 5 on it. It's just that 2x becomes a exponent, right? We can do all that, right? But let's do baby steps. All right, so then back to this one. So can we drop our logs now? There's one log base 5 on the left with an argument piece, okay? There's one log base 5 on the right with an argument piece. So then we can set the arguments equal to each other, right? So we have, can I expand that? Are you guys okay with me expanding it right now instead of rewriting it? Because we're going to have to solve this baby, and we can't solve it unless I expand that argument on the left. So x plus 1 times x minus 3 is going to be a x squared. Minus 3x plus x is going to give me a minus. 2x minus 3 equals 5. So just like every single other equation you guys have solved with me since you've started your high school careers with me, it either breaks down to a linear or it breaks down to a quadratic. It's no different with your exponential equation and your log equations, guys. Right? If you're getting something bigger than that, double check your work. So then now I have x squared minus 2x minus what? 8, good. Because as soon as you see degree 2, guys, you should be thinking ax squared plus bx plus c and factor. If it's not factorable, then you have to use the quadratic formula. Hence why the quadratic formula is also on your 30-1 formula sheet, because you're not guaranteed everything will be factorable. But is this one? Yes. Right, so then we factor it. So then x and x, 4 and 2. I need a negative 2, so the 4 is negative, and the 2 is positive. So x equals 4, and x equals negative 2. If you get a negative answer, does that automatically mean it's extraneous? Right, depends on your originals, right? That negative 2 doesn't guarantee that it doesn't work. Go back up to your arguments. Because could I actually get a negative 2 answer? Yeah, it totally depends on your original argument. So go back up to my originals. I know that this little guy here, x had to be greater than negative 1. This one had to be, x had to be greater than 3. So which is the one I'm looking at? The 3. So this is my restriction. Right, so therefore, which one am I crossing out? Negative 2. So this one obviously does end up being a restriction or extraneous. But just because you get a negative does not mean it can't work. It totally put it back up and look at your arguments to begin with and your original restrictions. Okay, so just to show you guys the other way you could have done this, just to show you guys just the original, just at this stage here, I'm just going to rewrite this with Just give me 2 seconds. Boom, boom. Right. So do you guys agree that if I didn't change the 1, it would have looked like that? Right? So I still would have used my log laws. Okay. If I didn't change the 1, I could leave it. And guess what you would do at this step? Instead of changing this to a base 5, can I just change forms now? Right? So you could not change the constant, right, to the same base log. You could just now go log, the 5 becomes the base, the x plus 1 times x minus 3 becomes the answer, right, and then equals the exponent. Because remember, log, base, answer, exponent. So then you end up with this. Is that the same thing as what we did above? Right? So again, you don't have to get rid of it. I just find students that get rid of it and do it as the same base make less errors. Because a lot of times the students that leave it as a 1, they just drop the log right now and say that x plus 1 times x minus 3 equals 1. Is that very not true? Yes. Right? So again, if you choose not to change the constant over, that's okay, but just make sure you change forms properly. Okay? So if there's a constant of 1 in your original, when you change forms, it will no longer be a constant of 1. Right? And I'm not going to finish that because you guys agree that it's literally exactly the same work now? Yes. Okay. All right. So same thing. Will you move something over? Yeah, right? Because I'd want all my pieces with the X on one side, the pieces that don't have the X on the other. So then away you go. So you guys go ahead, do this one. I'll just do it quietly behind you guys. So remember, when the number's not written there, it's a base what? 10. So I'm just writing it in here just to clearly show you guys. Not that you have to write the base 10, but just as a reminder. Oh, -1. Sorry. I was looking at my solution again. So do you guys agree? No solution? Right. Right, so just keep going, guys. They are very similar. There is a definitely piece that I want to talk about once you get to D, but you guys keep working through them. Put up your hand if you get to a spot where you have a question or if you do something and you're not sure. Just with this one, guys, if we do the same base, right, we just have log base 2 of x minus 6. I just want to talk about one tiny little thing here. Goodness, x minus 6 plus log base 2 of x minus 4. And then on the other side, it's going to be 3 log base 2 of 2. You guys agree? Because again, guys, it doesn't matter what the constant is, right? You just throw the base or the log on it. Because again, log base 2 of 2 is 1. 1 times 3 is 3. It's just before you can use your exponent laws, where does the 3 have to go? Has to go up onto the argument, right? Before you can drop the bases, right? Because you have to have a log with a coefficient of 1 on both sides before you can drop the logs. Oh yeah, no. No, definitely not. So yeah, if you go right to log base 2 of 8, same thing. Right? So I'm just showing this step because if I was scared if I do log base 2 of 8, you guys would be like, what did you do? Right? Will it be log base 2 of 8 when I'm done? Absolutely, because log base 2 of 8 does equal 3, right? And that's the form it needs to be in before you drop your logs. Right? So then now you guys should be able to keep going because now it's exactly what we were just doing. Yeah. Everybody good with C? With D, again, you could do a base 2 log on the other side, but could I just change forms right now? Yeah, to me, I'd probably, because there's only one log on the other side, I'd probably look at this and just go 2 to the exponent of 4 equals x plus 3 all squared. If you hate that, do you have to do it that way? No, you could change this side to a 4 log base 2 of 2, which is just log base 2 of 2 to the exponent of 4 is 16. So if you rather do this, right, and then are we back to this anyway? Yes. So guys, with this one, do both answers work? What's the only restriction on this one? X. The only restriction on this baby is x cannot equal -3. Look at it closely. Is the square making it a big deal with the restriction? Because if I square it, is it always going to be positive? Yes. So normally x, you would say x squared, right? Plus 3, or sorry, x squared. X plus 3 all squared has to be greater than 0. That's all you guys are picturing, right? So are all of them going to be positive? Yes. The only piece that makes it 0 is the -3. So this one only has that restriction. It can be anything except -3. So both of those work. A common error, guys, that students do with this one is they take that 2 and put it here. Does that change the equation? So this one, you eliminate an answer if you do that, okay? So if you have a degree 2 in the argument, okay, leave it there. Do not use the power rule to bring it out front and then divide it off, okay? Because with a quadratic, you should be thinking, because it is a degree 2 in the argument, should you be thinking 2 solutions? Yes. So algebraically, because the algebra is actually sound, it's just you can't do that because you eliminate a solution. So if you're not sure what I'm talking about, picture that, guys. If you took that 2 and put it out front and divided it off, are we only going to get one answer if we do it that way? Yes. So that is algebraically sound, but you can't do it because you eliminate a possible solution by changing the argument from a degree 2 polynomial to a degree 1. So be careful that way. All right, and then your last one. So go ahead, do this one. I'll bring up the homework questions because some of you might be way ahead of me. So please make sure, guys, if you're done this one, I'm okay if you've got a few questions left on your assignment that's due today. You can work on that. But if you're done everything, then you can start on your practice from the textbook after you're done E, obviously. Oh, sorry. Oh.